Welcome to this program, which we are doing for you. This is basically for all the students who are preparing for the UG entrance conducted by IMB for the first time, right? So that exam is on 13 December. It was told in a webinar by the admission in charge of this particular program that they will be having calculus coming as a part of quantitative ability or a maths part. So we will be doing the first part of that over here. uh, we will do questions, and through questions we will try to revise the concept and also tell you about how to evaluate limit and how to use that concept of evaluating limit in continuity and differentiability. So first of all, suppose this is a kind of a question which I have for you. Let me say this first question is here: limit x tends to 0, x raised to power 5 minus 1 upon x square minus 1. Whenever you have to evaluate a limit, in this put 0, this tending to 0, this part you put here, you will get 0 by 0. So this means it is a indeterminate form. What is this form? Indeterminate form, right? So one of the method to solve this question is do something so that one of the 0 vanishes from this here or here. What can I do from here? I can do what? uh, find out common term, and then common factor in numerator and denominator, and then we can cancel that, right? This is x equal to 0. Wow, we are saved. Why? Because this is not 0 by 0. It will be 0 by 0 had this been 1 here. So this is not that indeterminate concept. I will just write minus 1 by 1. So this is a shocker, isn't it? Most of us will do mistake by seeing this and put over here 0 by 0 concept, which is not true. So the answer which has to be here, this is x tends to 0 here, and we will get our answer as a 1. So what is the answer? It is not here. Let's put a fifth one here, which is 1. Correct. Let us say, because we are understanding this concept, had this been 1 here, if suppose had this been 1 here, then of course we will get what? Indeterminate form, which is this. So please remember, right, if you're getting indeterminate form, then only the next step of cancelling or anything else will come. So let me tell you the first trick. If this is 0 by 0 or indeterminate form, then what we should do? Let's take this question over here. If this is the case, then do only one thing. The first thing you should try in 0 by 0, if you get that, please differentiate numerator. What you should do, you should differentiate numerator. This is a easy differentiation, and you differentiate also this. You can do by many methods. You could do algebraic division, you can take a common factor out, but this is the easiest. And you're writing an entrance examination. If it is an indeterminate form, use El Hopital rules, as you call sometime this as El Hospital's rules. Use that rule and get away with it. So what that rule says, if limit x tends to a, fx by gx is having indeterminate form. What that means? That f of a upon g of a is of the form 0 by 0 or infinity by infinity, or one more form we will take, 1 raised to power infinity. If this is the form 0 by 0 or infinity by infinity, let us focus here, then this limit will also be equal to x tends to a d by dx of fx, that is differentiate numerator separately and differentiate denominator separately. That is what I'm going to do here. If I differentiate, I'll get 5 x raised to power 4, and here I'll get 2x. Now this x will get cancelled. I'll get x cube here. So what is my answer now? 5 by 2x cube. If I put x is equal to 1, 0 gaya, 0 vanished. So my answer is 5 upon 2 into 1 ka cube, which is equal to 5 by 2. So had this been 1 here, suppose this question would have been limit x tends to 1, then our answer would be 5 by. Understood? Is it clear? Right. Let me see. Okay. Let us solve other questions. And idea is basically to solve questions and revise the concept. Let us, if this is one, let us do a correction here so that our question is correct. The answer was 5 by 2. Let us go to the next question, which is here limit x tends to 0. Again, we will put x ka value and check whether the form is 1 by 1 or not. Let's check. If I put 0 here, I'll get 1. I'll get 1. I'll get 1. I'll get 1 minus 1 upon 0, which is nothing but 0 by 0. So voila. So we have which kind of a form here? We have a form which is called indeterminate form. If indeterminate form, then the easiest way of handling that differentiate it. If I differentiate, I'll get 5 x plus 1 raised to power 4 and minus 1 has a differentiation which is equal to 0, and x ka differentiation is 1 bacho. Was khatam. Because one of the 0 has been vanished from here, I'll get my answer. What will be the answer? 5 into 0 plus 1. I'll put in place of x0 raised to power 4 upon 1. You may write 1 or you can ignore 1. So answer is 5. So second answer is 5. So it is so simple. You don't have to, expand it. Now let us again solve this question. Limit x tends to 0, sine 5x upon sine 3x. You have to remember now this formula, which is here. For getting out of this, that limit x tends to 0, sine of x upon x is equal to 1. Right, bachon? So if it is the case, please remember here, this x, whatever is written inside the bracket, inside sine, that should be tending to 0. You will get which kind of a form? 0 by 0 form. Easy peasy method in this is, I will write x tends to 0 and I will write what? I will not differentiate here. I will just do a little bit of algebraic manipulation to get my answer, which is multiplying and dividing and putting it in an organized fashion. I'll write sine 5x upon 5x, and I will write here sine 3x and here 3x, right? This is how it is there. But ये 5x 3x ऐसे ही थोड़ा ना multiply कर सकते हैं. If I have divided by 5x, then I have to multiply numerator by 5x. If I have multiplied numerator by 3x, then I have to divide by 3x. So now what is the answer? This term will be equal to 1. This term will be equal to 1. And this x and this x will cancel. What I will have now answer as 5 into 1 into 1 into 1 by 3, which is equal to 5 by 3. Right? Everybody knows this. Let me give you a super trick, which is here. A super duper trick. Go to whatever is written inside sin x. And this in language says if x is in the neighborhood of 0, then sin x will be tending to x. The only funda is that x tends to 0 means whatever is written inside that should be infinitesimal. If it is infinitesimal, see, it's a super trick. You will just get it like this: sine x will tend to x. Now this entire thing which we have done, all this is necessary if I know my concept in English. So if x tends to 0, kids, 5x will also tend to 0, 3x will also tends to 0. So why can't I write here limit x tends to 0? This is 5x and 3x. Just because sine 5x is tending to 5x, sine 3x is tending to 5x. Next step, the answer 5 by 3. So this is a, jugaad technique, shortcut. You can always solve. Let's take another example. Limit x tends to 0, and this is sine 7x by sine 3x. I will just write this as equal to, I will just write this as, here I will just write limit x tends to 0, you know what, 7x by 3x. It's so simple, so please remember that, it will help you. Now let's come to the next one, which is 1 minus cos x by x square. So this is here. Limit x tends to 0. This is all going to add up when we solve, evaluate limit or integrate. I have worked out this phenomenal thing for myself, that limit x tends to 0, sine ax upon sine bx is nothing but simply limit x tends to 0. Sine ax will tend to ax and sine bx will tend to bx. So this value will be a by b. I'll remember this. Now come here, 1 minus cos x. So how do we solve it? I will multiply by 1 plus cos x. Why? I'll just give you this. This is an alternate method. I'll multiply by 1 plus cos x. And I'll get what? X square into 1 plus cos x. What will I get? Limit x tends to 0. Look at this, it's so simple. Sine square x upon x square, and I had here 1 plus cos x. Sorry, 1 plus x is not there, 1 plus cos x is there, because that is a multiplying factor in numerator and denominator. This value is again tending to 1. So what do we have? 1 upon, because 1 0 has gone, numerator say 1 plus cos 0 is 1, so this is 1 by 2. So this is super cool. The other method which most of you would have learned, or let's take 1 minus cos x can be written as 2 cos x. Let's not do that also. Let's differentiate this. This will become 1 minus cos x ka differentiation, and this will be differentiation of x square. If I differentiate also, I'll get limit, abhi limit resolved nahi hui hai, so we'll write this again, 2x square 2x, and this will be nothing but plus sine x. Now this is simple. Sine x by x is nothing but tending to 1. So I'll again have answer as 1 by 2. So please remember, you can also remember this as a formula, that this value is equal to 1 by 2. So we have now figured out all the values. Let us put it 1 here. This is 5 by 2 and this is 1. This was a printing kind of a mistake, because x is equal to 0. If it was there, answer is 1 only. So I hope the initial part of, solving limits is complete and we are through with that, right? So initial formulas are here in front of us and we have completed this part. Now let us go to the next one. Next one is again a method which I wanted to share with you. This is called rationalization method, because sometimes in case of rationalization, differentiation could become messy. So let us solve this. This is an irrational function. Let us first check whether it is 0 by 0 or not. If I put x is equal to 0, bachon, this will be 1 minus 1 upon 0, which is 0 by 0. Hence it is indeterminate form. So let us use this method. What is the funda? I will rationalize and solve. So this is 1 minus x upon x. This will be equal to limit x tends to 0. I will multiply by rationalizing factor of 1 plus x minus 1 in denominator as well as in numerator. So let me multiply under root 1 plus x plus 1. what will happen? This will be, kids, x tends to 0, 1 plus x, because the square has become, and minus 1 ka square upon x into under root 1 plus x. It's so simple. Plus 1. You know? So this 1 and 1 will get cancelled out. What we will have here, limit x tends to 0, x upon x into under root 1 plus x plus 1. Simple now. This x is, wow, one of the 0 has vanished. Numerator ka 0 has gone. So now I will just put the value of x. This is under root 1 plus 0 plus 1. This is 1 by 2. That is my answer. Understood? So this is the method also to remember. Let me check whether it is clear to all of you. Done. Let us do the next part. There is another question which is there for you, right? Let me erase this ink which is there in front of us. This is the question. This is a simple question for revision of concept. This, please solve with me. Limit y tends to 0. Again check. This is under root 1 plus under root 1 plus 0 minus under root 2 upon 0. This is also 0 by 0 indeterminate. That's the first step we should do. Under root 1 plus under root 1 plus y raised to the power 4 minus under root 2 upon y raised to the power 4. Let us do the rationalization part. I will rewrite this rationalizing factor of the numerator plus root 2 upon under root 1 plus under root 1 plus y raised to power 4 plus root. This is rationalizing factor. This factor is here. This is here a under root b, and here under root a under root minus b. If I multiply this, I'll get limit y tends to 0. Let us write denominator first because nothing is going to change here. Under root 1. Let's not lose patience. It is going to be solved within a minute or so. This will become 1 plus under root 1 plus y raised to power 4, and minus root 2 ka whole square is minus 2. So this will become limit. This will become limit y tends to 0. Now let us see. Again I am stuck. Why? Again it is 0 by 0 form. So we are not stuck. Don't worry. We are not stuck at all. We are very close to our solution. 1 plus under root 1 plus y raised to power 4 plus root 2. Now what to do? Again this is 0 by 0. Again multiply by rationalizing factor, and then voila. Ah, now this will be clear. Right? Wonderful. I multiplied this. I'll write the result in a black color over here. Here. So this is limit y tends to 0. And we have what? This is root a. This is root a plus. So this will become what? 1 plus y raised to power 4 minus 1 ka square. This is wonderful. This will get cancelled. Y raised to power 4. Oh, ho, ho, ho. So this factor will also get cancelled. Now, what do we have over here? What do we have over here in denominator? 1 plus under root 1 plus y raised to the power 4 plus root 2 into, again in denominator you have bacho 1 plus under root 1 plus y raised to power 4 plus 1. Now because this y raised to power 4 has cancelled, here it is 1. So now we have our answer in front of us. We will just solve and write the answer, which will be equal to, which will be equal to, what will be the answer now? 1 upon, the first term is root 1 plus 1, which is root 2 plus root 2 in a bracket, and this term will become what? 1 plus 1, which is equal to 2. So this answer is 1 by 2 root 2 into 2, which is equal to 1 by 4 root. Slightly difficult, but why we are doing such kind of a questions? We are doing because we have got information from admission in charge of this entrance test that it will be slightly challenging. So if they want to give you a simple question, it will be like this, which is only one rationalization. If slightly challenging, then this kind of a question where you have two-step rationalization. Clear now? Okay, let us do further. Next concept in this. Sometimes you will get a question like this, which is a trap question. Let me help you with this trap question. If I solve it, it is a 0 by 0 form first of all. If I solve it, I will write under root 1 minus cos 2x is nothing but 2 sine square x upon x. Correct. So this will become, because this is 1 minus 2 cos x, and by mistake I will write it like this, 1 by x tends to 0, and this will be root 2 sine x upon x. If I write like this, I will say I am getting answer 2. It is not there. Question is wrong. They have done some mistake. Uh, I will get marks in this. This is something wrong. It is not. Right? Why it is not? Just from coming from here, I've made a mistake. Under root of sine square x is mod sine x. So this will be solved in two ways. I have to find left hand limit, that is x tends to 0 minus root 2 sine x mod sine x upon x, and I have to find out right hand limit. This is called bacho left hand limit at x is equal to 0, and this is called right hand limit at x is equal to 0. So this will become limit x tends to 0 plus under root 2 sine x upon x. Please be careful while you're watching it. Okay. How do we evaluate this? I'll put x is equal to 0 minus h or minus h where h is greater than 0. And here I will put x is equal to 0 plus h so that I get this superscript out of my concepts. So what will be this be? This will be better transformed to limit h tends to 0. So simple. Under root 2 sine, in place of x I'll write minus h. 0 minus h is minus h upon minus h. If I solve it further, because there is a mod, I will get root 2 sine h upon minus h. This limit is equal to minus root 2. And if I solve it here, right hand limit, I'll get limit h tends to 0 root 2 sine h upon h, which is equal to root 2. So left hand limit is not equal to right hand limit. As per the basic definition of limit, limit does not exist. This was the answer. All other answer was given to confuse you. So please remember this trick, this trap, and you will always get through this. Right, kids? Hope you understand this. This is a kind of a trap in which you get get caught. There could be a root 2 written in an answer. There could be some arbitrary answers which are written, which is here in front of you, and one of the option is limit does not exist. So please be careful of that. Right now, let me teach you one more part. How do we solve limit x tends to infinity? Whenever you have limit x tends to infinity and you have fx by gx kind of a term, so this will give you infinity by infinity form. Please don't start differentiating. Do like this. You need to divide both numerator and denominator by highest power of x. Highest power of x where in denominator. Please note, that's how we solve. Suppose you have a question like that, limit x tends to infinity, x plus 1 upon x square plus 3x. Then what is the highest power? X square. So divide it. You will get limit x tends to infinity, 1 upon x square, sorry, x upon x square, 1 upon x square. This will be 1 plus 3 upon 3x upon x square. So this will turn into limit x tends to infinity. See the beauty of it. 1 upon x plus 1 upon x square upon 1 plus 3 by x. Now see this. This term is tending to 0. This term is tending to 0. This term is tending to 0. So I'll get 0 plus 0 by 1 as an answer. So this is how I solve. The answer is 0. Okay. So had this question been like this, limit x tends to infinity, let us reverse this question, x square plus 1 upon x plus 2. If suppose this is there, again I will divide by highest power x tends to infinity. And what will be my answer? Limit x tends to infinity, x plus 1 upon x upon 1 plus 2 upon x square. This is infinity. This is 0. This is 0. This is 1. So answer will be infinity. Understood? The third variation. Limit x tends to infinity. Suppose you have x square plus 1 upon 2x square plus 3. Now again I'll divide by x square and let us see what answer we will get. Limit x tends to infinity, 1 plus 1 by x square upon 2 plus 3 by x square. Wow. So these three type of questions are there. To clear this concept, you will get 1 by 2 as an answer. So this can be 0 also answer. There can be infinity also, or 1 by 2. Understood? Take a screenshot, note it down, whatever you want to do it. Let us now use this here. What is the highest power? X square. I'll divide it. Limit x tends to infinity. This will become 1. This will become under root 1 upon x raised to power 4 plus 1. Why? Because x square coming in inside the root will become x raised to power 4. This is 1 upon x square plus 1. This will be equal to under root 1 minus 1 upon 1. Answer will be equal to how much? 0. Right? 1 plus 0, and this is minus 1, 0 plus 1. So 1 1 will get cancelled, you'll get answer as 0. So cool. Right? Remember that. Divide by largest power in the denominator. Now let us move forward. Let us go to this question. Okay, please remember how you have to do it. This is the type of form you might encounter. If x is tending to 0, please note this is tending to 1 and this is tending to infinity. So this is called, kids, 1 tends to infinity form. Okay, how do we solve it? This is an interesting form. How do we solve it? I will rewrite this limit as e raised to the power limit same x tends to 0, 1 by x, that is this part, right? And sine x plus cos x minus 1. This is a different version of a L'Hopital's rule. This will become sine x plus cos x. Can this kind of a form come? Yes. Now this is 0 by 0. Don't worry about this. This is 0 by 0. So now this question is limit x tends to 0. 0 by 0, I'll differentiate. Sin x will become cos x. This will become minus sin x. This will become 0 and this will become 1. Wow, 0 has gone. So answer is what? E raised to the power cos 0 minus sin 0 upon 1. Sin 0 is 0, cos 0 is 1, 1 upon 1 is 1. So this is my answer. So please note that if your limit is 1 raised to, if fx raised to power 5x tends to 1 raised to power infinity, right? Then use this. Okay, right? Let us go and solve this question which is in front of us. Again, look at this question. Which form is this? This is tending to 0. No, 0 plus 1. So this is tending to 1. Acha, 1 is to infinity. Hai. Oh my god, this is infinity. So how do we solve it? We will write e raised to the power. Just see the way it is done. Same limit. जो पावर पे है, जो एक्सपोनेंट पे है, that I will write as it is. And whatever is in the base 1 plus 2x fx, that I will write as fx minus 1. So what does this become? E raised to the power limit x tends to 0, x plus 3 upon x. See how simple is this, no? If I know the trick. If I don't know, this problem will never occur to me. Okay. So this will become e raised to the power limit x tends to 0, 2 times x plus 3 upon 1. है ही नहीं नीचे जीरो का ऑप्शन एक्स पे डिपेंड ही नहीं करता सो आई विल जस्ट डायरेक्टली पुट द वैल्यू 0 in x. It will become e raised to the power 2 plus into 0 plus 3, which is nothing but e raised to the power 6. Wow, this is my answer. Please remember what? If 1 raised to power infinity form hai, this is an indeterminate form, then limit x tends to a, fx raised to the power gx will be equal to e raised to the power limit x tends to a, same limit, gx जो exponent है gx, this will get multiplied with whatever is base fx minus 1. Okay, great. So now let us move and do one more thing. What is continuity? So let us do a one question for continuity. If a function is plotted, this is x and this is fx, this is x and this is f of x. In that case, a function like this will be discontinuous at x equal to a, because I have to lift my pencil. This is kind of an understanding. But if I look at mathematical definition, then I'll say limit x tends to a, f of x must be equal to f of a. This also has one more layer. This is broken up into left hand limit and right hand limit. Left hand limit is equal to right hand limit. That must be equal to f of a. If it is, then we say function is continuous. Right? If left hand limit is equal to right hand limit, or for that matter, limit exists, that limit exists, that limit x tends to a, f of x exists. If it is existing and it is not equal to f of a, then we can redefine f of a. We can redefine for this, and it will be called a removable discontinuity. Otherwise, on all other cases, we will say it is a discontinuity of second time, it is not removable. Okay, so let us check in this particular scenario or in this particular question what is given to us. So first of all, I have to compute limit x tends to 0, 1 minus cos x upon x square, because this is not having any mod or the value of function is not changing. It is safe to not evaluate left hand right hand, directly evaluate the limit. And I know from my previous background that this is equal to 1 by 2. If I have forgotten, Then also I can differentiate. I will get sine x upon 2x, and answer will be 1 by 2. This is fastest if you have forgotten. If you've not forgotten, if you remember this limit, then this is 1 by 2. So what is the funda here? Limit is 1 by 2, limit x tends to 0 is 1 by 2, and f0 is 1. So what kind of a case? If a limit will not exist, means the limit existing, but this is discontinuous. What is the case? Limit is not equal to f of 0. So what we can do, this answer is not there, this answer is not there. It has a discontinuity. It is removable, yes. How it is removable? We can redefine f of 0. This should be written here f of 0. We can redefine f of 0 as 1 by 2. If I redefine, then limit this particular function, the overall definition of function will give me a continuous function. Understood, kids? So removable limit is where you can change the value of f of a so that limit becomes continuous. Let's do this question now. Next question. This is also called signum function. I have to evaluate continuity. So first of all, I will write limit x tends to 0 minus f of x. I will write limit h tends to 0, and I will do transformation here by putting x is equal to 0 minus h, and now h is a positive quantity and h is tending to 0. This will become f of 0 minus h, or I can write this as f of minus h, which will be nothing but I have to put my limits also here. Limit h tends to 0. Here also this will be becoming limit h tends to 0. Just a minute. You will get your sum in front of you. Minus h. कहाँ से आया ये? यहाँ से आया. F of minus h. I have put in place of x minus h. So this will become, kids, h tends to 0 बच्चों. This is h upon minus h. Why? Because mod है, then minus will get removed. Value is minus 1. So left hand limit is minus 1. And please note it is not equal to 0, so it is discontinuous. It is as simple as that. What will right hand limit come? You can evaluate. That will come as plus 1. So you will have left hand limit something else, right hand limit something else, f of 0 something else. So of course, this is discontinuous. Let's solve this question, and then one question we will do on differentiability. Okay, right. So if it is continuous, then limit x tends to pi by 4, f of x has to be for continuous, for this has to be equal to f of pi by 4. And what is f of pi by 4 given to us as k? So basically, this question is not of a continuous question, continuous tika question. This is a question of evaluation of limit. I have to evaluate this limit, and that will be value of k. So let us do it. Limit x tends to pi by 4, tan pi by 4 minus x. I'll also tell you a trick over here of evaluation of limit. Now let us put x equal to 0. Upstairs is 0, downstairs is also 0, indeterminate form hai. I can do differentiation, but that will be very messy. Okay, so what is the funda? Always this is the first step, that I'll do the transformation that I have told you. In that I'll put x is equal to pi by 4 plus h. I've told you in right hand limit now. That's how I will do, and I'll put h tends to 0. So whenever, this is a trick, I will put it in red, so all of you, if limit x tends to a, if nothing is working out for you, please try this, especially in case of trigonometric, exponential, logarithmic functions. Please try this trick. Convert this x tend to a limit into limit h tends to 0 by doing this transformation, what, putting x is equal to a plus h. This most of the time will work. So what do I have here? What do I have here? Now I have here tan. Look at how simple it will be. Pi by 4 minus pi by 4 plus h, right बच्चों, upon cot of 2 times pi by 4 plus h. It is so simple. So this will be limit h tends to 0, tan pi by 4 and pi by 4 will cancel and this will be minus h. And what do we have here? What is here in front of us? Oh my god, 90 plus 2h. 90 plus 2h. Second quadrant. Trigonometry. Second quadrant. This is minus 10h of course. And as it is in second quadrant, this will be negative minus cot की जगह it will become tan because it is a pi by 2 transformation. So this will become what? Tan 2h. Understood? All of you? Clear? Tan h upon 2h and this minus and minus will get cancelled. So if you're not clear of the formula of tan h, that also does not matter. Write sin h upon sin 2h into cos 2h upon cos h. Right? This value, I have told you this is 1 by 2, this is 1, this is 1. Answer is in front of us 1 by 2. Understood? Clear? So this is how we can do these kind of questions. Please, once again, make this boxed x tends to a converted to a plus h. It will always help. Understood? Now let us go to the screen and see. Yeah. Sir, I want to ask, should I attend sessions on YouTube as well as in my zone portal? Shubhankar, it is your call. If it is there on your my zone portal, that will be more extensive session. But you can also attend this because it's a quick revision which is happening over here, right? So that is your call. Last question of the session, which I am doing it for you: how to compute whether this is differentiable or not. For differentiability, this is the concept. Left hand derivative at x is equal to 1 will have to be equal to right hand derivative at x equal to 1. So what is left hand derivative? It is simple. Just write h here and write f of 1 minus f of 1 minus h. बिकॉज वन के लेफ्ट में जा रहे हैं तो वन माइनस एच, तो वन से वन माइनस एच घटाएंगे तभी तो आएगा एच. एंड राइट हियर लिमिट एच टेंस टू जीरो. So always you can start when you're creating right hand or left hand derivative writing like this. Right hand है तो वन के राइट में वन प्लस एच होता है, एंड टू गेट एच आई विल हैव टू राइट एफ वन प्लस एच माइनस वन. Understood? These are the things which needs to be computed. We are in the last 2 minutes. Okay, so let me compute for you right hand limit. What is this coming to? F1 plus h means I'll take this value, so I'll write 2 into 1 plus h. In place of x I'll written this minus 3 and greatest integer 1 plus h. This is f1 plus h. And what is f of 1? F of 1 is 2 into 1 minus 3, which is 2 minus 3, and greatest integer of 1 divided by h. Let me compute this. Limit h tends to 0. This will become 2h minus 1, and this is 1, of course. And this is 2 minus 3 is minus 1 into 1 is 1 upon h. Correct? So this will become, because h is a very small quantity, so 2h will also, why a small quantity? It is close to 0. So 2h will also be close to 0. And 1 is very big quantity compared to 0. So this will flip its sign when mod will be removed. So this will become, this is a good understanding, finer understanding of mod ki 1 is more than 2h. So it will flip its sign, it will be 1 minus 2h minus 1 upon h. So what it will be, minus 1, 1 will be cancelled, it is equal to minus 2. So that is my left hand derivative. If you do not know these things, you will not be able to compute left hand derivative. Sorry, right hand derivative. This is all right hand derivative. I said by mistake left hand. So if I have to compute left hand, we have a minute left. Let me do it for you. H tends to 0 upon h. F1 is sine pi by 2. That's cool. That is 1. Minus sine pi by 2. And the mistake you can do, you can write pi by 2 minus h. Don't do that. Pi by 2 into 1 minus h. That is what the question is. So this will become limit h tends to 0. Sine pi by 2 is 1. Minus sine. If I multiply this, it will become sine pi by 2 minus sine pi h by 2 upon h. So this will be limit h tends to 0, 1 minus cos pi h by 2 upon 0. Is it clear? Right? Sine pi by 2 minus pi h by 2. Sine pi by 2 minus theta is sine theta. 1 minus cos h by 2, cos pi by 2 upon h. Since h is 0, let me not do the artistry. Let me write it as h. If h is 0, cos 0 is 1, so this is 0 by 0 form. I will simply differentiate it. This will become sine pi h by 2 and multiplied with pi by 2 because I'm differentiating with respect to h, and this is here 1. So what is my answer if I put h is equal to 0, pi by 2? This and this are not equal. So function is not differentiable. Understood, kids? Function is not differentiable. Though this is continuous, it is not differentiable. At your leisure, you can solve and do whether it is continuous or not. It is continuous, but it is not differentiable. So let me now say bye bye to you. This is what I wanted to tell you, a quick kind of a revision. We are through with also limit continuity and differentiability. I will do with you differentiation, AOD, and integration. Okay. If you have not joined, please join. You can do mock test. There'll be a mock test available on the site. We will create one or two more mock tests for you so you are better prepared on 13th of December writing this. See, nobody knows, but the idea is I'm prepared for whatever is coming my way and I'll crack, because less awareness, less preparedness, I will have my chances bright enough. Okay, so all the best to you. Prepare well, study well, and get into your dream destination. Please do subscribe our channel. Thank you very much. Bye bye. Take care. Bye, bachon. I'm ending my stream. Bye bye. Take care.